Topcoder is an automated grader. As such, all questions you may have about the problem should already be answered in the problem statement, because there's no person on the other side. At interviews, however, this is not the case. You need to think about the questions you should ask to uncover the problem's constraints yourself. In this video, we'll go over the questions you should ask about Zigzag, and we'll use the canvas to record the answers to these questions. With any problem, the very first questions that should come to your mind relate to the size of the input. I always ask myself, how large can my input get? In the case of Zigzag, this means knowing two things. What is the maximum length of the initial sequence, and how large can each individual element of the sequence get? Let's look at the Zigzag problem statement. Conveniently, Topcoder has a nice section that outlines these. It's called the constraints section. And that's how important they are. They have their own section. So let's record the answers to these two questions on the algorithm design canvas. And I'll name this canvas Zigzag, or maybe even Topcoder Zigzag. And then we can say that the first constraint is this. 1 is smaller than n, smaller than 50, so n will denote the length of the sequence is between 1 and 50, and then each element is between 1 and 1000, so we can say 1, each element will just denote the sequence with the lowercase a. Right, excellent. So we've now scoped the problem. This is where many people stop, but we're definitely not done yet. Let's now make sure we understand the specifics of Zigzag. Whenever there's a problem related to subsequences, you should pay special attention to how a subsequence is defined. And there are roughly two options, and the difference is quite subtle. Option 1 is that the elements must be consecutive elements of the original sequence. Or option 2, the elements in the subsequence don't necessarily have to be consecutive. So which one is it for Zigzag? Let's look at the statement again. And if you read it, you'll see that the subsequence is obtained, and this is the right sentence, by deleting some number of elements, possibly 0, from the original sequence, leaving the remaining elements in their original order. So we can definitely write down that the elements don't have to be consecutive, because we are not required to delete consecutive elements. So we can say elements don't have to be consecutive. Right. Good. Finally, let's pen down the edge cases we can think about and what we're supposed to do about them. What about really short or really long subsequences, right? Normally a sequence is zigzag if it alternates at least once between up and down. That's our intuition. So we need at least two movements or 3 numbers. So zigs and then zags, or zags and then zigs. But what about sequences of only 1 or 2 numbers? Are these considered zigzag? Similarly, if the entire initial sequence is zigzag, are we allowed to output that as a solution? Let's look at the statement again. And in this case, the first sentence, or actually the first paragraph, is going to be pretty telling. And look at this sentence. A sequence with fewer than 2 elements is trivially a zigzag sequence. Right, so then we can say something like 1 and 2 element subsequences are zigzag. And then this here, a subsequence is obtained by deleting some number of elements, possibly 0, tells us that okay if we don't delete anything, right? So this edge case, we also have it covered. And finally, the problem says that the consecutive differences need to alternate so that the sequence zigs and then zags. But what about a difference of 0? Is it okay to have two consecutive elements of the same value? And looking at the statement again, it says that if the differences between successive numbers strictly alternate between positive and negative. And so we need to write down strict alternation required, right? Excellent. So now we have 6 constraints that frame our problem very well. All of these impact the solution we can consider. Some have very strong impact, like the size of the input. Others will slightly change the code we write. For example, whether strict alternation is required or not. But all of those are important at this stage. So hopefully this video gave you a good idea of the kinds of things you should be thinking about before you jump into idea generation. No matter what problem you solve, make sure you frame it well, just to make sure you're solving the right problem. And so with that, we're now ready to move on to the next area of the canvas, ideas.